Plastic. Now, if you're like me and many other Americans, you probably have a plastic bag full of other plastic bags somewhere in your house that you just don't want to throw away because you don't want them to be clogging up the local landfills or wherever they go. Now, researchers at UC Berkeley have also realized that this is an issue with the American population. They realize that we hoard these plastic bags because we don't really know what to do with them. The current process for recycling these bags involves chopping them up and burning them or getting rid of them in that way, which completely destroys the properties that we strive so hard to put into making these synthetic plastics. Now, 1/3 of all the plastic production in the entire world is polyethylene, which is the variation that makes up our plastic bags, and certain variations go into making our plastic water bottles as well. This polyethylene is made up of chains from 2,000 to 10,000 carbon atoms surrounded by hydrogen atoms. Now, what that looks like is if my head were a carbon atom and these two squirrels represented hydrogen atoms, we would have my head being in the center and the two hydrogen atoms around that carbon like this, and then another one attached on this side and this side for 2,000 to 10,000 carbons long. Now, these chemical characteristics give plastic the properties that we have worked so hard to achieve. Things like resistance to breaking down over time, resistance to chemical reactions, and kind of that long-term durability that we count on in our plastics. However, this presents a bit of a problem when we try and recycle these plastics into things that maybe are more usable and more valuable to society. Researchers at UC Berkeley have discovered a way, using another catalyst, just like in our first video, to add a functional group or another organic chemical onto our long chain of polyethylene to make it do something valuable. So these researchers have found a way to insert what is called a hydroxide ion. It is an oxygen and a hydrogen that are fused together. They've substituted one of the hydrogens on that long chain of carbons with this OH group, and doing that has given this plastic completely new properties. So before they were able to insert this functional group onto our chain of carbons and hydrogens, plastic really doesn't want anything to do with metal or anything that has a charge. It's very non-charged. It's one of the characteristic properties of this plastic. However, inserting just a few of these hydroxide groups onto this long chain of carbons and hydrogens makes it very adhesive, surprisingly, to metals and even to latex paints. So what? Why does any of this matter to you? Well, this new adhesive version of our polyethylene chains can be used in major knee and hip replacement surgeries to coat the new implants and help those new implants interface better with your bones and your joints. Additionally, this new adhesive plastic can be used to hold everyday items together like milk cartons and toys, as well as coating electrical wires with special adhesive coatings. Now, unless you're 95 or 5 years old, these things might not seem like they're that applicable to your day-to-day life, but it's going to impact us in a series of other ways. This research is really the first way that we've been able to upcycle plastic. Until this point, we haven't had a method of turning our unvaluable used plastic into a new product that might actually add value to our kind of capitalistic society. And because of that, this is really the first motivator for big companies to maybe take a lot of that plastic that is polluting just all over the world and turn that into something that we can use in other ways to better benefit humanity and to clean up some of the plastic that we have put out into the world. Now, I've decided to start using an impact scale to give my own assessment of how I feel these different research papers and projects will impact us as a species over the next X amount of years. And I've assigned this research paper with a rating of 6 out of 10. Now, it might seem like there aren't a lot of major benefits yet, with this really only being applicable to some kind of major replacement surgeries of joints and toys and electrical wires and things like that. But I truly believe that the motivation for big companies to start taking these plastics out of the environment and turning them into something that is more valuable and useful will have a longer term impact on both the economy and the ecosystem of our whole globe. So that concludes our episode for today. Thank you for tuning in. As always, my sources are cited down below, and we will see you next week.